Hi, I'm Jason Belk, and today I'm going to talk about some struggles that I've seen in my experience as a network automation engineer. A little bit about myself. I have a background in network automation. I was in the Cisco IT network operations team for the campus and branch team for a number of years. And then towards the end of my time there, I started learning automation as well as teaching others. And hopefully through this presentation, you're going to pick up some of these best practices and take them on as your own. So that way you can avoid the common pitfalls in network automation. My current role is working with Cisco as a network services orchestrator, NSO, developer, evangelist. So even though this talk doesn't really touch on NSO specifically very much, I'd love for you to take a look at our product as well as see what it can do in your environment for network automation. So just take a look at this slide, and at the top we have a quote from Robert Burns, where he says, "The best laid plans of mice and men often go awry," which is just a shorthand way of saying oftentimes we try our best to think of all the possibilities, but even still problems happen. And we have here a picture, a meme of Gru from Despicable Me. He has a whiteboard easel where he says, "Step 1 in my plan, I want to learn automation concepts. Step 2 in my plan, I'm going to begin my automation journey." And then without looking at step 3, he said he doesn't see that step 3 is actually hit a major roadblock. And then he turns around and sees that we all often hit major roadblocks in our automation journey. We all have the best intentions. We have high hopes. It all sounds good on paper, which is just an American way of saying it sounds good in theory. There's something about what we're trying to do that in all best case scenario, we expect nothing to go wrong, but oftentimes things do go wrong. We hit major roadblocks, and what can we do as network engineers, network automation professionals, managers, try to think of ways to help mitigate these problems and solve them before we run into them. And hopefully through this presentation, you will see some of these pitfalls and then hopefully remember them as you encounter them and before you encounter them, so that way you can avoid them yourself. First, we're going to talk about how to fail. So you can see some of the examples and the pitfalls on how you can fail when you're getting started in network automation. And then the second half, we'll talk about how to succeed. And it's not totally bifurcated, and there'll be some intermingling within those different topics. So don't just totally ignore one or the other, because hopefully you'll learn from both. First, we're talking about how to fail and pitfalls to avoid when getting started in network automation. So the first pitfall I think you should pay attention to when you're getting started in network automation is don't start with high risk, difficult problems. My first project when I was a network automation engineer, just as a network engineer getting started in automation, was for iOS upgrades. And for those of you who are not familiar with the process, upgrading a Cisco router or switch, especially older models, requires numerous steps. And there's plenty of different failure points that can happen along the way. So this is definitely a high risk and difficult problem. The reason it's high risk is because when you're upgrading the software on these different infrastructure devices for your network, you can have lots of different points of failure. And when you're building automation, you really want to control for the different points of failure when you're building and testing your automation. I was working with dozens of hardware platforms across different software versions, over 600 branch sites. And these different branch sites had different levels of speed on the latency, which comes into play when you're trying to provide a large file transferred into the device. So that way you can then upgrade from that file to the new version. And another problem when I was trying to solve this that made it difficult was when we were testing, we were trying to find those problems before actually having the production in our live lab. It took sometimes 5 minutes, sometimes up to an hour, depending on the hardware platform, to actually run through our tests. So that's something to keep in mind too, is that when you're starting your first project, there are all these different variables in play, and you want to pick something that is quick and easy to do and doesn't have a lot of different failure points. Because for iOS upgrades, you could have a failure point in the hardware. Hardware could just go kaput when you reload the box. We definitely saw that happen. You could have a failure point in the software. Maybe there's a bug in that new software release that only shows up in the wild when a certain level of traffic is occurring. You do it in off hours, but even still, you never know. You can also have failure even in your code. Of course, we try to test and think of all the different possible scenarios, but even still, we run into issues, mistakes, the oversights in our code, and you have failure points at different layers in the process. Don't start with these high risk and difficult problems. You want to start with something simple, something isolated, ideally something with few dependencies where you're just trying to change a few minor components on the configuration maybe, or gather some operational state, and you have a quick win for your team to build up the confidence you need as a team, not only confidence in you as an automator, but for the rest of your team to have confidence that your software is going to deliver quickly and on time and better than it could have been done manually. So another pitfall to avoid: don't assume an all or nothing mindset. And I hope this is somewhat self-explanatory, but let me give an illustration. In our automation journey, we wanted to create a single source of truth, or sometimes called golden config, for all of our campus and branch devices, for the WAN and LAN, for those network engineers. We wanted to be able to say, we know exactly what is on every single network device, and we have it all templated out, every piece of configuration covered, and our automation can then manage all that configuration and have no more errors or outages due to some type of mistake in the configuration, especially when you're dealing with 600 sites, and each of those different sites have multiple devices upstream as well as downstream. We want to make sure that everything is squared away. And the all or nothing mindset comes in is that even within each configuration, there are different what we call config stanzas, where on Cisco devices, you have different sections of the configuration. You have, say, routing configuration, quality of service, access control lists, just host name and basic clock information. So there are lots of different components to keep in mind. Some of those change more than others. And some of them have more variation than others and different exceptions depending on what site you're working with. And this added a lot of complexity when we were trying to automate. So this don't assume an all or nothing mindset applies because we ended up never completing the project, never pushing it to production. We got a lot of it done in terms of the templates, but it ran out of steam because we had an all or nothing mindset saying we had to have it all in the single source of truth, all in the golden config, or else we might as well not have this run in production. And so when you're automating, don't think so black and white. Think sometimes maybe we'll just focus on the components of our configuration that are most error prone. Let's say access control lists. People mistype an IP address. People mistype a port number. That's definitely an area where you can have automation make a huge win. And that's something to keep in mind when you're building your different automation use cases. You don't want to assume an all or nothing mindset. So this next pitfall to avoid: don't fail to learn good debugging processes. And by this, I mean, I know as network engineers who are starting to automate, or depending on what your background is in infrastructure, debugging seems very intimidating, something that those professional software engineers over there are doing. But it doesn't have to be. You can start small. You can do what you can to really help move the ball forward as you're learning in your network automation journey, because it's a learning process. And debugging is a key part of that learning process because it allows to give you insight into what's going wrong into your code that's not performing as expected. Because if your code works every time, you're probably not going to debug very much because you know exactly, there's nothing wrong. Sometimes there are problems that you don't see, and you still want to proactively look ahead and make sure there's not a false positive. But all that to say is that you don't want to fail to learn good debugging processes, because down the road, you're eventually going to need them. So a personal example for me is in this iOS upgrade project, we're trying to push these large files to these remote infrastructure devices. And it was never completing. We would start the transfer, get everything prepped for the transfer, and then after a number of minutes, we would check and the automation was done and the file was not transferred, so we couldn't actually do the upgrade. It needed a new file in order to upgrade. Well, we had to go in the source code for the library, Python library we were using, and find an optional flag to be able to look at the actual stream of text that is going on. For Ansible, there's other options you can set in the log settings to be able to see from a network perspective exactly every single command that is going on in the background. In our situation, we weren't using Ansible, we were just using generic Python, but the same process falls in place. You want to find those optional settings that oftentimes are turned off by default and turn them on, so that way you can see exactly every piece of information that's going on in this particular type of debugging. And that allowed us to see that file transfer was never completing because it timed out. And in iOS devices, these infrastructure devices, if it times out, there's no partial file remaining, which I didn't know at the time. So these are all different learning steps along the way. And so we discovered the file was never transferred, and we were able to adjust our timers within the code so it could account for transferring a large file. Because typically these type of automation frameworks are expecting you just to send a simple command, and then it waits for the prompt to return back. And then if no prompt returns back, it cancels out and ends automation for you, which is a good feature by normal. But in our case, we wanted to be able to have that prompt not return back after a while, longer than normal, because we wanted to transfer that file. So more generally, some other good debugging processes is basically just looking at the variables in your code, commenting out the components, all of them in your playbook, and just have one task uncommented. Does it work? 2 tasks, 3 tasks. And then once you hit a failure point, dig deeper, see what the values of your variables are at every step of the process. And sometimes some problems won't show up until you have multiple components running at once. So another pitfall, don't superficially copy code without comprehension. So this sounds like, duh, of course I wouldn't do that, but we all know out in the wild, we run into a problem, we go to Stack Overflow, Google search, we find the snippet we want, copy and paste it in. And for learning, for getting started, that's totally understandable. This is not a hard and fast rule in every situation. This is something that you as an automator need to learn with wisdom, that you don't copy and paste and just walk away. You copy and paste if you need to, and then step through the code. How does this interact with my other playbooks? How does it interact with my other code? What was the original author trying to do? And if you end up reusing someone's code and not modifying it in any way, put in a comment, give some source, give a link to the original place you found it, so that way other people know that you didn't write it, you're not taking credit for someone else's work. I was working in a project back at Cisco IT. I had an engineer in another location who was getting all kinds of acclaim for the work he had done for a web application. And I looked into his source code and it had tons of comments and variable names that looked kind of weird. And I took his source code, Google searched it, just took the code, took some snippets and searched it, and found it was just straight dumped from Stack Overflow, which, yeah, he got it working, but it's kind of embarrassing to think that he was taking all this credit for something that took him months to complete, where, in fact, he didn't actually do any work. He just dumped it from online. So as you're learning, walk through what you're learning and don't take credit for other people's work and shortchange yourself in the learning process. So this next pitfall sounds kind of like, don't forget to brush your teeth. Don't forget to tie your shoes. It's something we all know and love or hate, and sounds automatically obvious again. Don't forget to document your work. So this is something that we all scratch our head and say, yes, we know we need to document our work. But documentation can really look like a lot of different things. It doesn't have to be this long and onerous process. It could be as simple as a recording, just like I'm doing right now. I could take some work I've done recently, spin up a WebEx or Zoom or something else and walk through how I set up my installation, what libraries I use, what versions I'm using, what kind of unassumed assumptions I have when I'm setting up my different environment, because those are all things that when someone else is trying to troubleshoot or reproduce your code, or you yourself are trying to do that in the future and you've forgotten some of those details, you wouldn't have those written down somewhere. And the easiest way to do that is just to record yourself in a virtual meeting. Other quick ways, of course, are using Markdown in a source control like GitHub, GitLab, writing down your installation guides, steps you went to reproduce and set up your original environment, and to go through your different automation steps, as well as maybe including a Vagrant or Docker file if you're at that point in your automation journey and you're able to use those platforms. Vagrant and Docker files allow other people to easily set up their own virtual environments corresponding to what you're trying to do in your automation. So an example from my experience, after my IT operations time, I was in a network automation consulting role. And the people we were working with had a heavily customized Ansible deployment that was ginormous. It was so large that you really couldn't even run it on your laptop. And had so many customizations that the dedicated automation team was spending their full time keeping up with the bugs, deploying new features, and didn't really have any documentation. And they were trying to bring up the rest of the network engineers to be able to use this. So we were teaching network engineers Ansible, showing them the way. And this is an example of there was no documentation for these new people to learn. So we actually had to spend our resources going through their source code, going through all their Ginger templates, YAML files, naming conventions, playbooks. And it took weeks, months, off and on, to figure out and kind of reverse engineer some documentation. So don't pay someone else to figure out your documentation for you. It's something that you should be doing as you go along in the way. And that helps not only your sanity, but being able to train and onboard and spread out that responsibility to other people, which is a concept I used to mentor and teach other people on my team. Is you don't want to be creating an invaluable job that is boring. And by that, I mean, you don't want to be making yourself invaluable because people have to ask you questions about how your stuff works. That's not a fun job to be invaluable. You want to be invaluable because you've created such high quality documentation, high quality software, high quality engineering work that other people are able to figure out on their own, and you're able to continue moving on to new things rather than just continuing to maintain the old thing and explain how it works time after time. So this next pitfall, and the last one we have before we move on to how to succeed, is don't hugely over-engineer the solution. We have a picture here from what is called a Rube Goldberg machine. A perfect example of over-engineering, where somebody wanted to have a self-operating napkin just to clean your mouth as you're eating. A lot more effort than is totally needed to wipe your face after or during a meal. And we always think, it's those other people who over-engineer a solution, but it's important to have a humble and self-reflective attitude in your design process. Am I taking things too far? Am I introducing too much complexity that's going to make it hard for us to troubleshoot? Am I overthinking all the possible problems we can involve rather than using the 80-20 rule? 80% of the effort covers most of what we need to do, and that last 20% requires a lot more effort to cover over. So a personal example from my experience is we had an internal framework in our IT organization for network engineers to use. It was meant for network automators to be able to quickly get their automation up and running, and then to be able to deploy it to production. The problem was the people who had designed this particular framework had introduced a lot of over-engineered, in my opinion, complexity. They had Docker microservices from the internal Docker registry, Python keyword arguments, decorators, connecting to Java Spring framework with a GUI and REST APIs, and all in a CI/CD framework using Linux and internal Artifactory. And for a network engineer, and I know, at least in my experience, and the rest of people on the team at the time, we had no experience with any of that, let alone barely a working knowledge of change directories in Linux. So setting up our environment, troubleshooting our environment, even if a lot of it was abstracted away from us, errors still happened. And just the overhead of this framework made the learning curve for network engineers just starting to try to get to automate feel like, man, this isn't for me. This is like what software engineers do. I was just trying to, do some routing, switching, wireless or something. And this learning curve was just way too steep. So it had the unintended consequence of causing network engineers to be disinterested in automation, feeling like it's not for them. Rather than the old adage from Ratatouille where you say everyone can cook. As long as you're trying, you're moving forward. You just start with the simplest possible thing. And not to say that those technologies that were used are not something that down the line you're going to want in terms of CI/CD, Artifactories, Docker. Yeah, those are all great technologies. But in terms of getting started, and people who have never done this before, it can kind of scare people away. So just think about that. That's a cultural thing to keep in mind. As well as don't over-engineer a solution. It makes it really hard to actually finish your project. It's not just for frameworks, but for actually specifically projects. If you over-engineer it, then you're not able to ever reach the finish line because you have so many different balls you're juggling at the same time. So now, how to succeed. Tips and tricks from experience. So my first tip on how to succeed is make learning a priority. And this is probably one of the tougher ones because especially if you're still in operations and still getting tickets come in and having people call you and message you about different issues that are happening, it can be really tough to carve out that time, I know. But you still have to make learning a priority. You have to set aside that time in your calendar and find that personal motivation, the reason why you want to learn. It's not just something that someone on high has been pushing down on you. You have to learn automation. You want to have to learn, have that motivation yourself, as well as set aside the time and carve it out without interruption. No social media, no YouTube videos, just focusing on the tasks at hand. And having a humble and teachable attitude is a key component of that, as well. As you move along the process, you're going to have to adjust to that learning curve. And over time, it's going to be easier. You're going to run into the same problems over and over again, and it's going to be faster. But initially, it's going to be tough. You're going to feel like you're learning to walk again, putting the training wheels back on your bicycle, so to speak. For engineers, that's really tough because we're really used to being competent in what we do. Now when we're starting to move into a new domain of software engineering and automation, we have to relearn how to learn. Speaking of which, another way to help you learn quicker is to teach others what you are learning to reinforce those concepts. And so whether that's as simple as sharing with the person, I guess now virtually next to you on your team, what you're learning, or creating or using, if your team has them, brown bag sessions, virtual sharing sessions of what am I learning right now? What's just a simple thing that I have in my day-to-day applied to my job, some automation concepts, or even just more generally, I've learned how to create Ansible playbook that can gather some information from our network devices, and starting with the smallest task possible, and then following all the examples you can find. So this one is almost, I'd say, one of the most important ones we've covered so far is automation is more than a working playbook. Within Ansible, we have the concept of playbooks, which are your tasks and sequence of events that are executing your automation. But automation is more than that. You have the business process around your automation. It's not just you in a vacuum. It's you and the person who asked you to do that automation, or it's you and that person who asked you to solve that case or change that configuration, or that business unit who needs the new access. So, and this is something that not as your first project because you don't want to get too complicated, but to keep in mind down the road is that you need to worry about the business process around your automation and think of what are the things that people are doing that's taking up a lot of time more than just the automation, the things we did manually on the configuration before. So some examples from my experience is that when we were doing these iOS upgrades, we were paying contractors to do these upgrades for us. And now we had this automated process and they were dragging their feet to use the new automation. And so it was incumbent upon us to provide that motivation, show how easy it was, and that it wasn't threatening their jobs in this particular situation, to have these people actually use our automation and increase the reliability of their work. Another example is that when we were doing these iOS upgrades, we'd have what we call pre and post checks, where we would issue a series of commands and see what was going on the device before and after the upgrade. And then we would store that information on our ServiceNow change request, so that way we could have a documented record of what occurred. And so we actually ended up including that within our automation steps and having an API way to update those ServiceNow change requests, because that was part of the work. It wasn't just doing the upgrade itself, but documenting what we had done in our central change management system. Finally, another final example is updating our engineering labs access control lists. So oftentimes when we were updating these different access control lists, we had to get InfoSec approval, and that was a separate team in a different time zone. And it usually took 2 weeks for them to approve it. And so we ended up having a format of submission that was much more standardized and automated, so that InfoSec could approve it in a much shorter time turnaround. So a lot of it is working with outside stakeholders and finding a compromise that works for both of you. So now, transitioning from individual projects to group work, this is probably something farther down the line after you've been doing 6 months, a year, is that you've built up your confidence and you want to start doing group projects rather than just me, myself, and I creating our automation. And so now you're going to start interweaving more experienced people in these projects. I think that's a really important part, because I had seen automation projects that didn't succeed because the project manager, the people involved, there's nobody who had a more bird's eye view of problems that would occur, things that people got stuck. So you want to have an automation veteran, whether that's within your team or if you're just getting started, you might need an outside consultant or services to help mentor your team and making sure those automation components that you don't run into pitfalls. Of course, you want to gently reinforce some software's best practices, so that as you're doing your different automation components, that your team works together and you have your source control and everything in a secure way. And another quick tip for moving from waterfall to agile, so assuming that's part of your process, is that you want to watch out for project managers who maybe are so steeped in the waterfall method of doing things sequentially with a long planning rather than short sprints, that they fall back into the old ways. And so you want to be able to have a way of gently reminding those project managers, and now possibly rebranded as Scrum Masters, that what they are doing is now in this new process rather than the old process that would take years to accomplish. And now my final slide. This is from what we call our network automation delivery model that our NSO business unit has created. That's not just for NSO, but really more generally for all automation. You can see the link on the bottom. And the last concept is that lasting change for automation takes years, not just weeks or months. You have to be patient. And what we have here is a timeline of different phases of getting started and then moving into build automation practice. So we have an entire timeline on the bottom there, going from define, demonstrate, deploy, expand, operationalize, and run. And this presentation is only 30 minutes, so I'm not going to deep dive into all these different components, but hopefully it gives you a bird's eye view that it's more than just deploying a few scripts. It's more than just, pushing out playbooks. And there's a business process, there's best practices around choosing a well-defined team, well-defined goals, having ways of defining what is done. When your automation is done, you can move on to the next project. And all of that is defined on our DevNet page, where our team has painstakingly laid out all of those different steps and processes for you to understand that when you're trying to change your team, you're trying to deploy automation to a larger organization or even just a smaller team, it can take a while. And there are certain steps and best practices that can help speed that along. And finally, just to provide a plug about myself and our team, is that I'm from the Cisco Network Services Orchestrator NSO team, where we have a configuration management automation platform that I think is really the best in the industry, that can help you in your Ansible deployments. We're using Ansible to configure your infrastructure, and you can use it hand in glove with Ansible and NSO in order to manage your configuration for your network devices. We have some further links here. You can access to a free sandbox as well as plenty of labs, and we'll continue to put out new content so that way you can learn for yourself how NSO can help you in your automation journey. Thank you.